The automation paradox. When safety systems create risk. In 2015, engineers promised us something revolutionary. Safer factories, safer roads, safer hospitals. Artificial intelligence would eliminate human error, the leading cause of accidents worldwide. But what happens when safety systems themselves become the risk? This is the story of a hidden contradiction, a technological irony, a silent vulnerability growing inside the world's smartest machines. This is the automation paradox. And to prevent 1. Human fatigue, 2. Distraction, 3. Poor judgment, 4. Manual override mistakes, 5. Physical collisions. In theory, automation reduces chaos. In reality, it sometimes relocates it. Key concept introduced. When responsibility shifts from humans to algorithms, accountability becomes abstract. Factories replaced supervisors with sensor arrays. Cars replaced reflexes with predictive models. Hospitals replaced observation with machine monitoring. But safety in automation is layered. 1. Sensor input. 2. Algorithmic interpretation. 3. Decision execution. 4. Physical action. And failure at any layer can create new, unexpected physical consequences. Autonomous vehicles. The illusion of fail-safe. AI vehicles are equipped with 1. LiDAR. 2. Radar. 3. Computer vision. 4. Collision avoidance systems. 5. Emergency braking. But here's the paradox. When drivers trust the AI too much, they disengage mentally. This is called automation complacency. Case breakdown. A driver activates autopilot. The system performs flawlessly for 40 minutes. Then suddenly, a sensor misclassifies a stationary truck as an overhead sign. The AI doesn't brake. The human reacts too late. The very system designed to prevent accidents created overconfidence. This is not simply a software failure. It's a human-machine trust failure. Key insight. AI safety systems often assume 1. Humans remain alert. 2. Environments remain predictable. 3. Edge cases are statistically rare. But physical reality doesn't follow probability models. It follows physics. And physics doesn't forgive. Industrial robotics. When emergency stops become hazards. Modern industrial robots are programmed to 1. Detect proximity. 2. Slow near humans. 3. Shut down instantly if interference is detected. This sounds safe. But here's what engineers discovered. Sudden emergency stops in high-momentum systems can create secondary dangers. For example, 1. A robotic arm carrying a heavy component freezes mid-motion. 2. The suspended object shifts unexpectedly. 3. A nearby worker enters the safe zone, assuming shutdown means stability. 4. Gravity completes what the algorithm didn't anticipate. Safety shutdown becomes structural instability. AI stops software, but it cannot instantly stop. 1. Mechanical stress. 2. Stored kinetic energy. 3. Hydraulic pressure. For suspended loads. The result? A false sense of security. Smart buildings and fire response systems. Modern buildings now use AI to 1. Detect smoke patterns. 2. Predict fire spread. 3. Lock or unlock exits dynamically. 4. Redirect elevator systems. But what happens if the algorithm misclassifies? In one scenario, smoke from a kitchen malfunction triggers automated lockdown. Certain stairwells seal to contain spread. But the model's containment logic conflicts with human evacuation patterns. People move toward doors the AI has sealed. Confusion escalates. Time is lost. Safety optimization becomes evacuation friction. The deeper problem. AI systems optimize for statistical containment. Humans optimize for instinct. When those goals conflict, seconds matter. Healthcare automation and life-critical systems. Hospitals now rely on AI for 1. Medication dosing. 2. Patient deterioration alerts. 3. Automated ventilator adjustment. For surgical robotics, an AI system detects oxygen irregularity. It recalibrates ventilator pressure automatically. But the sensor was slightly misaligned. The system overcorrects. The medical team trusts the alert system and delays manual verification. This is called automation bias. When humans defer to machines even when warning signs feel wrong. Automation bias explained. Studies show people are more likely to accept incorrect machine advice than correct human intuition when the machine is labeled AI-powered. This is not a coding flaw. It's a psychological vulnerability. The cyber-physical crossover. AI safety systems are digital, but their consequences are physical. A compromised AI system controlling 1. Traffic lights. 2. Power grids. 3 smart cranes, 4 water treatment valves, can convert digital manipulation into physical disaster. The paradox deepens. The more safe automation becomes, the larger the attack surface grows. Because every safety protocol is another programmable entry point. The black swan problem. AI safety systems train on historical data, but rare events black swans are underrepresented. Examples: 1 unusual weather reflections confusing vehicle sensors. 2 simultaneous sensor failure during maintenance. 3 cascading shutdowns triggered by minor anomalies. AI is exceptional at known patterns. It is fragile in the unknown. Humans improvise. Algorithms optimize. And optimization struggles with chaos. Why more safety tech can increase risk? This is the core of the automation paradox. The safer a system appears, the more humans relax. And relaxation reduces vigilance, which increases vulnerability. Examples: 1 pilots over-relying on autopilot. 2 drivers texting in semi-autonomous cars. 3 security staff ignoring manual inspections because the AI is monitoring everything. Safety tech reduces friction, but friction sometimes forces awareness. Designing safer safety systems. So what's the solution? Experts suggest: 1. Human-in-the-loop systems. 2. Redundant verification layers. 3. Transparency in AI decision logic. 4. Mandatory trust calibration training. 5. Fail operational, not just fail-safe design. Fail-safe equals system shuts down. Fail operational equals system maintains controlled function during failure. A critical distinction. The future: coexistence, not replacement. The goal is not to remove automation. It's to redesign our relationship with it. AI should: 1. Assist awareness. 2. Not replace responsibility. 3. Support judgment. 4. Not suppress skepticism. True safety requires human intuition plus machine precision working together. Artificial intelligence is not dangerous. Blind trust is. Automation is not the enemy. Complacency is. The future will not belong to those who build the smartest machines. It will belong to those who understand their limits. Because sometimes, the greatest risk is believing there isn't one. Subscribe for Prime Security Solutions documentaries.